Hello, and welcome to this episode of the Satellite Image Deep Learning video podcast series. In this video, I catch up with Alistair Francis to learn about the Iris annotation tool. Iris is an image annotation tool which Alistair and his colleagues at the ESA F-lab have developed to perform rapid segmentation of multispectral and multimodal imagery. It uses a semi-automated approach and has a simple, easy-to-use interface which greatly increases the speed of annotation. Alistair is a research fellow at the F-lab in Frascati, Italy. He completed his PhD at the Mullard Space Science Laboratory at UCL, and his research is focused on image analysis problems in remote sensing, using a variety of supervised, self-supervised, and unsupervised approaches to tackle problems such as cloud masking, crater detection, and land use mapping. Through his work, he has been involved in the creation of several public datasets for both Earth observation and planetary science. I give you Alistair. Hi, Alistair. How are you doing?
Hi, very well, thanks.
Fantastic. Now, you're one of the developers of Iris, which is an annotation tool. Is that correct?
Yeah, it's intelligently reinforced image segmentation. So it was actually about 3 years ago. A colleague of mine, John, and I were trying to do some cloud masking for Sentinel-2. And we were looking around for datasets and realized there were a few scenes annotated here and there in different datasets, but really nothing that was kind of machine learning or deep learning specifically applicable, where we expect to have at least hundreds of images annotated. So John was like, oh, just give me a few days. I'll like code something up quickly that we can like use to paint over Sentinel-2, because we tried it in QGIS and it was just like really difficult to do. And then half a year later, he was still like beavering away, making this tool. And since then, I've kind of continued developing it. So the basic premise of Iris is basically that in each image that you're trying to annotate for a segmentation task, there's actually a lot of correlation between the pixels. So like one scene, there might only be a few kinds of pixels that you're going to be seeing in that scene. And so a really simple model like a random forest for many tasks can actually represent that relationship very well.
Right. And
so you basically give it a few of your own labels and iterate with a random forest to predict the mask across the image.
That's really nice.
Really speeds up. Yeah.
I'm not aware of any other tool that uses a random forest. There's other tools that use like some related approaches, I suppose, but
yeah, I'm not convinced. I mean, we haven't done tests. I'm not convinced that the type of model like matters that much when you're at the level of a few thousand pixel annotations on a single scene. It would be interesting to try with different implementations like an SVM or something like that. But yeah.
And was there a reason you couldn't use any other annotation tool for annotating this data?
Yeah, so we spent a lot of time, I'm sure a lot of people have, when we decided to make a dataset, looking around for annotation tools that could help. And I think there's sort of two like families. There's the sort of big GIS package ones that maybe people from remote sensing are more familiar with, something like QGIS or ArcGIS, and you're drawing polygons. And everything we found was just really difficult to find like a streamlined tool where you could actually do things quickly and you didn't have to, navigate through menus and all of that stuff. And on the other end were very streamlined, very nice, sometimes semi-automated tools, maybe like Labelbox and RoboFlow. And they're all, I mean, I think those are a bit newer now. But at the time, there were a few of these this type of image annotation tool. But they're very general purpose for sort of machine learning applications. And the real thing that remote sensing has that these other fields don't is like data cubes. So we're very rarely worried just about red, green, blue, right? So like in most applications, certainly for Sentinel-2 and even in high resolution satellites, you still have like often a near infrared band or other bands. And really, we didn't have anything where we could like streamline a process where we could visualize multiple things at the same time, switch between them like seamlessly all over the same data space. So Iris is kind of filling that niche, if you like, of this remote sensing having high dimensional data. But really a lot of the remote sensing tools that are really, really focused on like geographical representations of things, we kind of throw that away and just make it into like a raster, which is much easier to play with from a machine learning point of view and on the back end. So I guess it's kind of hybrid between those two worlds.
Cool. It'd be really nice to have a look at it now.
Yeah. Okay. So I mean, Iris is. I'll share my screen. So maybe I'll just show you the config file of the project I want to share with you today. So basically, each project in Iris is going to be defined by like a big config file that's held on the server that you're running it on. And so Iris runs as a web application. So there's there's Python code in the back end essentially, and then there's JavaScript on the browser end, which the user, the annotator, actually interacts with. But as a sort of project administrator, you set up this config file that basically tells Iris, okay, where's the data coming from? What's it like? What shape is it? What classes do we have? Etc. Etc.
Yeah.
So this demo today, I think Cesar Ebar showed you on a previous show, actually, Iris working on cloud masking, which he used for his fantastic cloud masking data set. So instead of showing you cloud masking, I thought I'd show you basically an application with change detection over paired Sentinel-1 and Sentinel-2 patches. So what we do is we take Sentinel-2 scene from about 2 years ago, and then one from a similar time of year in 2022. So it's normally 2020, 2022. And then we take a similar Sentinel-1 scene. And this is all done, by the way, offline. So Iris doesn't handle this. This is all, you have to do all this pre-processing yourself.
Yeah, okay.
But Iris is taking this raster data. In the future, we're also going to add Prisma, which is a hyperspectral instrument, to this project. And the idea now is to basically mark some changes. We define changes to be sort of like, permanent, like changes in the way land is used, right? So it's not like vegetation becoming dry. It's like someone building something where there wasn't something before, or destroying something, or rebuilding, whatever.
Yeah. Okay.
So that's the application. If we just go through this super quickly, so we have some boring stuff up at the top, just about where the application is running, etc., its name. This is basically how it finds and indexes the data. So each image in your data set will have an ID, and this is just telling it how to kind of find those bits of data. So we have pre-S1, pre-S2, and post-S1, post-S2. So Sentinel-1, Sentinel-2 from before and after. Okay. And then we have some things about like the size of the data, etc., etc. I'm not going to go into all of this. The key thing here is we have two classes. We have no change and change, and we define the colors for them. And then we get into the sort of the meat of it, which is the views. So the views basically define functions that take you from this data up here to red, green, blue visualizations on your screen in the browser. So there's some simple ones. So we have the pre-S2 RGB. So this is the red, green, blue composite from the pre-S2 satellite bands 432. Okay, so et cetera, we have some SWIR in case there's something interesting in the multispectral, and everything we have pre and post, right? So we've defined all of these ourselves, and we have an NDVI in case it's useful. We also have the Sentinel-1. So the Sentinel-1 here, I've just taken the log representation. So Iris supports some basic algebra formula as well of VV and VH. So red is VV, and then a sort of greeny blue will be VH, and same for post. Okay, so that's basically it. We also have a little Bing Maps plugin, which might be fun to use. So that's now running. I'm already running this, so I can navigate to the front page. So this is what you see when you open up Iris as a user. So actually, at this moment, this URL is publicly facing the World Wide Web, right? So I'm not running this locally. This is actually on the website. So I can say I don't have an account. I can make a username.
Oh, we can't see the website. We're still looking at VS Code.
Oh, sorry. Let me. Right. Yeah, I see.
There we go. I can see it now.
Do you see my mouse?
Yeah.
Okay. So we'd see this. We can say I don't have an account. We can make an account. And this is Iris. Okay, so when you're a new user, if you haven't made any masks, you get this nice help menu that tells you a few things about Iris, but we can jump in.
Mm-hmm.
Okay, so we see here, this is a scene over Los Angeles, I believe, one of a few. And we see here on the left, the RGB, and then the Sentinel-1, and then the NDVI. So it looks like, to me, the NDVI isn't going to be so useful here. So we can remove that, like that.
Oh, you're just dragging the interface to change it?
Yeah, so there's just pluses and minuses that you can, and you can add different views, you can change them. So yeah, and then we've also got, so this is our first view group, right? And now we can change view groups to the second one. And this looks quite similar, but if we look, these are actually post. So if we remove this NDVI, we've now got post RGB and post S1. And if we just flick between them now, we can see how we can start to annotate some changes here. So what I found in the sort of playing around that I've done, so this project's in its early stages, we haven't actually started fully annotating the dataset yet, but just messing around with Iris with this data, I found that the Sentinel-1 is quite good at picking up big changes. Okay, so right in the center of the screen, we see this big change in the Sentinel-1 signal right in the middle. So I'm going to zoom in here, and it looks like, yeah, something's been built. This ground area, this sort of groundworks area looks fairly similar, so I'm not going to label that. And I'm going to up here. So I'm using lots of hotkeys as well, but there's menu buttons for all of these, so I can pick my classes and I can start painting pixels.
Right.
And then I'm going to also paint some pixels that are not change. So this blue color is going to define not change, and I can keep looking. So this, to me, looks like it could be a change, but it could not be. So there's a lot of interesting things with painting roofs, where roofs are sort of cleaned or painted, and they look really, really different from one year to the next. But on the Sentinel-1, there's really no change. So I'm going to assume that this is a roof that's been painted, in the intervening couple of years, or cleaned, so that it has a much higher reflectance.
Yeah.
So I'm going to actually label that as no change. And then we can, let's look for a couple more interesting things. So this, maybe that is a change. It looks like the Sentinel-1 does change a little bit. So I'm gonna call that a change. We'll say that's not change. And then I'm also going to look specifically. So because I'm using a random forest, right, I want to actually find things that I think the random forest is going to find difficult. So this roof, I know isn't a change. It's actually a roof that's been cleaned, because there's no change. I mean, it's clear that it was there before. It's just white now. So I'm going to mark that as no change deliberately, so that the random forest knows, okay, these kinds of roofs that change color, I'm going to ignore those, right? So we've only given it a few examples, but we can train the model. So the model's been trained and has now sort of propagated its predictions across the image, and you see it's a bit of a mess. So that's okay. We can very quickly give it some. So I'm switching here between different views of different colors, but I'm giving it some more no change, and then we can quickly train it again. See, it's starting to improve. What's interesting about change detection compared to something like cloud masking is that it does seem like we're in a much sort of higher dimensional space, because we have all the bands before, plus the Sentinel-1, plus all the bands after, plus the Sentinel-1 after. So the model actually takes quite a while to sort of get up to speed with what you're trying to do, because it's quite a complex space, but it keeps getting better and better. So I've played around with these images for sort of, half an hour at a time, and like the performance keeps on improving and getting more and more precise. So I think this counts as a little change here.
And just a question on that. So that obviously you're doing the evaluation like visually, like to check, okay, it's getting better. But if you had like a couple of images that were annotated like pure ground truth, could you somehow use those to give you like a metric of how well you're doing?
That's an interesting idea. So we do have a couple of ways of diagnosing what's happening with the model in Iris, not specifically a sort of full ground truth, given that I think in most circumstances we envisage Iris being used to create that ground truth, right? But we do have a sort of holdout validation set. So when the AI is trained, we take a few pixels at random and keep them as validation. So we can see roughly what the model's doing with the data we give it with this confusion matrix. We also have, which we don't see right now because there's only me annotating, but Iris by design is, let me just save this mask and I will log out of my user account and I will log in as the admin because we can see a few more things there. So although we don't have sort of validation against ground truth in Iris, we do have an admin page which can give you some information about the way that the users are interacting with one another in terms of how they're agreeing with one another. So if I go back to this, I think is this a different image? I think
looks
this is
the
a different
same
one. Is it? Yeah, it is. Okay. So I'll quickly draw some of the same things that we would. I mean, I haven't been, annotating very carefully, so the score's very low. But this 48 here basically tells me that someone else annotated this image, and between us, we have a 48% agreement in terms of F1 score. So if you have lots of people annotating the same images, you can kind of, by sort of crowdsourcing your efforts, work out, who's in most agreement with who, and which annotations you think are most trustworthy versus a group of people. So if we go into here, now we can see that the admin, so that's me right now, has made one mask, and also the user that I created before has also made one mask, and we each have a score of 48. So you can see how that scales to lots of users making lots of masks on different images.
I'm just curious, have you done any sort of, or had any insights from this sort of user comparison table on the annotation tasks you've been working on?
Yes. So the main project that I used Iris for in the past was the original one we designed it for, which was a Sentinel-2 cloud mask catalog. And we did about 500 images, but we found it really, really helpful. So what we did was we took a holdout set of like 10 images that we actually picked ourselves, like hand sampled, that were interesting features that we wanted to discuss as annotators. And we basically both sat annotating these as long as possible to get as high agreement as possible with each other. Sort of we were doing like sort of try to asymptotically approach the same annotation style between the two of us, right? And iron out any differences in what we thought a thin cloud was versus a thick cloud, et cetera, et cetera. So Iris was great for that because we could just do it all in the tool. And then at the end of the annotation, after we had annotated all our images separately, we took a sort of 50 image validation set and also annotated them together again. Although this time we sort of didn't try to copy each other's style. We tried to do it independently and then see what the agreement was, so that we got an idea of kind of human to human agreement in the task. Which was interesting, and Iris really helped with that. I'm quite excited to try some projects with kind of, lots more annotators, where we have, say, a dozen annotators. And I know Cesar with the CloudSend 1.2 project really like stepped up the quantity and volume of data going through Iris. And I spoke to him, and it was really interesting to hear, when you have sort of dozens of annotators using it, how these metrics are helpful, and also where they can be improved in the future with future development of Iris.
Presumably it would help with like debugging particularly challenging images, or even features in images that maybe you need additional annotator training on, for example.
Yeah, exactly. And so you can imagine a kind of, like almost like a training pipeline where you have a dummy project that is just there for people to hone their skills on, and then you graduate to the real annotation project. So I know that the mask isn't looking particularly impressive right now, given all the annotations that Iris is putting in, but I can assure you, if we carried on for a while, Iris would start to really hone in on some quite specific changes. And actually, I found that doing this for, as I say, maybe half an hour, Iris starts to spot things that aren't so obvious, and then you go away and look and really like peek at some pixels, and actually you start to convince yourself that maybe Iris has found something that you didn't notice before. So I mean, it's a very different approach to change detection data sets in the past, which I think are almost all sort of quite precise polygonal representations of buildings that have changed. So I think there's plus sides and downsides to using Iris in this application, because I think these precise polygons that a lot of change detection datasets use do have some semantic value of saying, like, this is the very, very specific outline of a building that's been demolished or constructed.
Yeah.
At the same time, in Sentinel-2, 10-meter resolution, it's pretty hard to make a precise polygon.
This is a huge building.
Yeah.
Question on the models: is the model parameters shared across all users, or would each user be training their own model?
No, so that's one of the sort of our founding sort of philosophical principles behind how Iris works is we want every image to be a blank slate, the model to have no biases from other parts of the data set. So there's two reasons. One is the whole data set will become biased in a certain direction, right? Because a random forest is only so good, and LA does not look like Shanghai, and Shanghai does not look like Beirut, but all of these things have changes in them. So you need a model with a lot of expressibility to be able to handle all those different cases, which we assume that the model that you train on this data set in the end will have, right? So like a convolutional model might have more ability to use spatial information to get other context clues that might help it. But for a single pixel method, which we kind of need to use for this speed of, I mean, you can see how quickly it trains and repopulates the image with data. For that kind of speed, we really want to stick with single pixel. And if we start making a sort of single model that gets bigger as the data set goes, then we end up with a sort of biased end result. So we almost want the model to overfit to each image.
Yeah. And then I suppose you're just storing the parameters of that random forest in the database somewhere.
Actually, no. So that's what's interesting. So even with it might be a good idea to do it as a sort of extra, is to be able to save the model out. Currently, there's no option for that. So the model is kind of instantiated. Every time you press train, it creates a model, it trains it, it predicts the rest of the image. But really what's important is the pixels that you've annotated, because that's what generates the specific model. And after you annotate for a while, at least in a scene, if you keep training a model, there's not so much difference between the outputs of each random forest that you train. But you can also alter some parameters of the model. So you can change like the number of trees that you have. So basically, I like to start with a low number of trees. And then basically when my AI score starts dropping, I then start bumping up the number of trees. But if you start with too high a number of trees, then you kind of overfit. You have to control it. And you can also add a little bit of spatial information. Some of these work well in certain instances and some of them don't. So you can add like an edge filter, which kind of tells the random forest if it's close to an edge or not. And you can also do a mesh grid, which basically it gives the model like a coordinate location in the image. So in a 3x3 mesh grid, it basically gives the random forest a number between 1, 2, 3, 4, 5, 6, 7, 8, 9 of where it is in the image.
Right.
Which is useful if there's different things happening at different parts of the image. But it means you have to annotate more because it will just overfit to those 9 coordinates if you're not careful. So there's pros and cons to using these features. And you can also, if you find that you think that one of the bands is unhelpful or it's overfitting to that band, you can actually remove, say, this band from the model's training data to sort of simplify the problem, which makes with overfitting. And lastly, you can also kind of apply this suppression filter, which basically will, if there's a very small annotated change by the model, a small predicted change, which is surrounded by no change, in this case, as the background class, it will kind of cancel out that prediction, which can help like clean up the model output if it's very noisy, which sometimes happens.
Amazing. And for somebody like yourself that's quite skilled at using this tool, can you sort of estimate how much time is saved, say, on annotating that image using the machine learning assistance versus just brute force?
So we do want to do some tests with the change detection specifically, where we actually go away and do it manually. But me and my colleagues need to find the time to actually go away and do an image manually, because it will take a lot longer.
Yeah, nobody wants to do that.
yeah. But I think the other thing that's maybe surprising, certainly in this application, is because it's actually quite hard to spot some of these changes that are happening in the image. And if you start annotating a few of the more obvious ones, Iris begins to find things that you might not have found before.
Yeah.
So I think you will save time, but you'll also probably end up finding some changes that you might not have spotted. So and similarly, so not similarly, so in terms of cloud masking as a problem, we found that basically the model sort of saturates in performance after literally a couple of minutes of annotation. So within a couple of minutes of flying around annotating pixels in the image, the model has kind of reached its like point of its convergence in terms of performance. And there might be some systematic errors in the image that you have to go around and correct with a paintbrush, which can actually take a long time sometimes, because if the model's just not learning the relationship you need it to, then unfortunately you have to go and correct it yourself. But with change detection, what seems to be happening is that as we go, the model gets more and more and more refined until it starts spotting things that weren't obvious to the human eye to begin with.
Sounds like such an experience actually using this tool compared to just the dumb approach of just annotating pixels.
I mean, it's definitely funner in some ways in that it's quicker. It's also frustrating because sometimes random forests are random forests, and sometimes they just don't quite do what you want them to do, or they learn. It's like they're very good at learning like a cheat that gets them the accuracy that they want, but actually it's not sort of physically what you want them to learn. But you end up kind of as you use Iris, you start to realize that it's much more about learning how to interact with this model than it is about your own annotation skill. It's more like, how do I give the model something that's going to make it learn a certain behavior?
That's interesting, because we often assume that annotation is kind of a low skill task, but actually using this kind of tool, it becomes a much more skilled task and probably more appealing maybe for people to use, but also changes the perception of what annotation is about.
I think that's fair to say. I mean, for example, if you flood the model with lots and lots and lots of a background class, right? So I decided there was no change, and I sort of very lazily put a big splodge of no change. Then you're kind of flooding the model's training data set with not low quality, but kind of low information pixels. And so actually you might find that the model starts performing worse because you've like given it too much of the same thing. So you actually, I found from personal experiences, going around and using a sort of smaller paintbrush to begin with and building up like a high quality training set for the model as you go is often more fruitful than very quickly painting large areas. Which I think is counterintuitive if you approach it for the first time. So.
Cool. I see that it's on GitHub Iris in your tab.
It's you can see the screenshot. So the GitHub is open. People can come and help out. I'm very open to any pull requests or collaborations, feature requests. I have a to-do list, which, to be honest, at the moment is more of a sort of wish list because I don't have too much time to really do the big features. But I would say some of the sort of key things that I'd really like to see in Iris, hopefully in the next year, if I find the time, is some way of embedding more spatial information into the model. Because currently, although there's the edge filters and things like that, that there are certain tasks where you really need like spatial information from a wider field of view. The technical problem with that is if you give it too many of these like features, then it's just going to overfit. So there might be some some way of doing like a spatial feature extraction and then like a PCA on those to kind of reduce the dimensionality of the data somehow. And some other cool ideas, maybe having like multiple different models within the same image. So you could maybe partition the image into two and like train two separate models in those two areas if you think that those two different areas need very different models.
Yeah.
And also some more class structuring. So one thing that we've been looking at is like maybe doing a semantic change. So not just it's a change, but it's a change and it's, changed through construction, or it's changed through rewilding, or whatever that definition you might choose. But we would want a model that just found changes versus no changes, because that's the sort of primary distinction that we want to make in the data set. Then we'd have a second model that would kind of do subclasses within those. But all future plans, unfortunately.
Yeah. Not probably more than a long weekend, I would guess.
Yes. Yeah.
Fantastic.
Yeah.
If people want to follow your personal updates, where's the best place? Would be Twitter, LinkedIn?
Yeah, I'm pretty bad at all the PR stuff, but I guess LinkedIn, people are welcome to reach out to me there.
Yeah, fantastic. All right. Well, thanks so much for the introduction to Iris, and I'm looking forward to using it myself and trying this completely different approach to annotation.
Great. And just thanks to you for having me on. And if anyone, yourself included, or any of the viewers have any questions about Iris, please feel free to get in touch. I'm very happy to help.
Fantastic. Okay. Bye then.
Great. Thanks.